right. So now what I'm going to do, now that you've learned about one way you can measure the velocity of the dart, I'm going to talk about a second method. We're going to call this method 2. And in your lab, what is this called? In the lab, it's energy and momentum, right? So energy and momentum. And again, our goal, our end game, is to find the muzzle velocity of a dart as it leaves the barrel of a dart gun. Now this is really cool. What we could do is we could take our dart gun, fire the dart, it'll leave the gun with a speed. It's then, what we could do is we could, from the ceiling, we can hang a cardboard box or a Dixie cup and shoot the bullet into that box. It's going to hit and stick on the back wall. And because it has energy, what's going to happen to our box? It's going to swing up. This is called a ballistic pendulum. Then if we measure the height it climbs, there's a way for us to work backwards from the height the box swung up to, all the way back to finding the muzzle velocity of the dart. That's pretty cool. Now, to do this, we need to look at this in 3 separate locations. A, when the bullet comes out of the barrel. B, the bullet hits the box and they start to move. And then C, when the bullet and box have swung up to their maximum height before they swing back down. Now, all we're going to know in this is how high they've swung up. So how can we find the speed of the bullet from just knowing how high these swing up? Well, let's look at from B to C. From here to here. Let's just look here to here. This is the swing. So we're going to work backwards from knowing how high the box swings up to finding how fast these are going together. We're going to call this V prime. That's not the speed of the bullet. That's what we're looking for out here. This is the speed of the bullet and the box together right after the collision. Make sense? Now, what kind of energy does this have at B? Kinetic. The box is moving with the dart. There's kinetic energy. So the kinetic energy at B will equal, what kind of energy does it have at C? Potential energy. What's the formula for kinetic energy? 1/2 mv prime squared equals, what kind of energy does it have at C? You said what? Potential. What's the formula for potential? mgh. Now I want to be careful. What is this mass? Mass of the box and the mass of the what? Dart. But it doesn't really matter because what happens in this formula? Yeah, they cancel. So we find that V prime equals the square root of 2gh. And that's the velocity of what? Anybody? Dart and the box as they move off together. But we don't want that. We want the velocity of the dart before it hit the box. So now we're going to analyze from A to B. And this is the collision. Yeah, what are we going to use to find the speed of this before? What kind of physics are we going to use from A to B if it's a collision? Yeah, so from A to B, we're going to do collision. The momentum at A equals the momentum of B. What is the formula for momentum? ma, the mass of the dart times the velocity, muzzle velocity of the dart, right? Equals, what about the mass afterwards when they're moving off together? Mass of the dart plus the mass of the box all times v prime, the velocity of those moving off. But what do we know that to be? We just figured it out, right? So now all I got to do is solve this for the mass of the dart. And I'm going to do all of this here. What it's going to be, it's going to be the mass of the dart, or excuse me, I want to solve this for Vm. I apologize. Vm, the velocity, muzzle velocity of the dart, is the mass of the dart plus the mass of the box times square root of 2gh, right? All over what? The mass of the dart. I divided through. So that's how we would find the muzzle velocity using this experiment. What data would we need to take? Heights, right? Anything else? Mass of the box. What else? Mass of the dart. Make sense? And you'd probably want to do, again, 8 to 10 trials. Shooting that bullet into the box, seeing how high they swing up. The tricky part is figuring out how high they swing up. Slow motion or high-speed camera, if you have an iPhone, works well. There's another method that you can use that I'll talk about when I show you the equipment to figure out how high it swings up. It involves putting a string in it that's just loose and then shooting it in, and when it shoots up, it pulls the string, and if you measure how far it pulled the string, you can measure how high it went. It's kind of cool. So that's the first method. But I really like this next method, or this next energy momentum method. And in this, we're going to take our dart, we're going to shoot our dart into a box that's sitting on a table. And the bullet's going to go hit the box just like before. Well, now what's that box going to do? It's going to slide. It's going to slide off and finally come to rest after it's moved some distance d. Velocity is 0 there. Make sense? Now, how would we find the speed of the dart if we only knew how far that box slid off? Well, we're going to have to do the same kind of thing we did before. A, the bullet flying on its own. Oh, I'm out of time. We'll finish this method up tomorrow.